Okay, here's going to be our review for our final exam in Algebra 3, if you happen to take this. We're going to work 34 of these problems listed. We didn't finish the last chapter, so we're not going to get to those. And so we should be able to follow through this, go over it, and make sure you're good to go for your exam. First thing, number 1, convert the angle to radians. Leave your answer as a multiple of pi. Now, converting to radians, if you're already in degrees, like we have 30 degrees, you need to multiply by the fraction pi over 180. If you remember that pi is equal to 180 degrees, so what you're really multiplying by is 1. It's just going to change the way it looks. So what we need to do is we need to reduce this fraction 30 over 180. That's what we end up having. So if we can get 30 over 180 reduced, we'll be good. So you can get your calculator and you can type in 30 divided by 180 and hit math, enter, enter, and we should get 1 over 6. Now do not type pi in your calculator, okay? You're just going to write pi down. So in your calculator, you're typing 30 over 180 and you're going to get 1 over 6. But when you write your answer, you're going to put 1 pi over 6. So we should have A as our answer there. Okay, now the other direction says we're going to start with radians and we're going to go to degrees. That means that we're going to take our conversion fraction, which was pi over 180, but we need to turn it upside down because the rule of thumb is whichever one you want to end with, that's the one that needs to go on the top of your fraction. So in number 1, we wanted to end with radians, so we put pi on top. On number 2, we want to end with degrees, so we need to put 180 on top. Okay? Then you're going to reduce everything. Now the lovely thing here is you have a pi in the top and you have a pi in the bottom, and they cancel. The rest of it is, can you just type this in your calculator? So basically you have 5 halves, so 5 divided by 2 times 180. Hit enter, you get your answer is 450. Okay, so that's our first two. Moving on. It says find the angle of smallest possible positive measure that's coterminal with the given angle. So you have to know what coterminal means and you actually know how to find them. Now if I've got 631, now that's much larger than one circle, because remember one whole circle is 360 degrees. Well, if you read this, it says the angle its smallest possible positive measure. That means, guys, it has to be in between 0 and 360, okay? So this is too big. What we need to do is we need to take a circle off. 630 means that you've come around and you've done a whole circle and then you went some more. So you want to take the excess off. So you need to remove a circle. So subtract the whole 360. So I have got 631 minus 360 is 271. 271 is in between 0 and 360, so we're good here. It meets the requirements. Smallest possible positive measure. Coterminal just means they're going to land in the same spot. So basically, it's a tiny little thing right in there. So that's where 271 is, and 631 just means that it rotated around a second time and landed there as well. But we need 271. All right, go to the next one. Suppose that theta is in the standard position and the given point is on the terminal side of theta. So give the exact value of the indicated trig function. So it sounds pretty intimidating, but what I need you to do is I need you to draw the graph. I need you to plot the point 3, 4. Now remember, your first number tells you side to side and the second number tells you up and down. So we're going to come over positive 3 and then we're going to go up 4. All right, so that's where our dot is, and we want to connect from the origin out to that dot. And if you've drawn it like that, you can connect and make your right triangle, and the right triangle is what's going to give you some lovely information. You have 3 on this side, and we went up 4 on this side. Now, what we need is we need to find the hypotenuse. Now, If you've forgotten your Pythagorean triples, then you might have to go back and do your theorem. But hopefully you know 3, 4, 5 is a Pythagorean triple. If you forgot, then go back and do a squared plus b squared equals c squared. And you're going to get 3 squared plus 4 squared equals c squared. So we got 9 plus 16 equals c squared. So 25 is c squared. When you take the square root of both sides, you get 5. So 5 is your hypotenuse. Now you guys need to remember what sine is defined as. Remember your some old hippie caught another hippie tripping on acid? That's your main 3 trig functions defined. So sine is some old hippie. So opposite over hypotenuse. So the opposite side is 4, hypotenuse is 5. So we need 4 over 5, right there. C. Okay, use the appropriate identity to find the indicated function value. Rationalize the denominator if applicable. If the given value is a decimal, round your answer to 3 decimal places. Okay. Number 5 says cosine. We want cosine if we know that secant is equal to -8. So let's just think for a second. What's the relationship between cosine and secant? Hopefully you guys remember that over and over and over again, we had to learn that cosine was the same thing as 1 over secant, or you could come from this approach. Secant is the same thing as 1 over cosine. They're reciprocal functions, which means that we can turn them upside down. So if I do this entire equation and I use reciprocals, I can do the reciprocal of secant is cosine. Now that doesn't look like I turned him upside down, but I did. I tell you what, let's put an in-between step in here so it makes more sense. Write it like we're doing reciprocals. There we go. I put 1 over what I have, and then I got 1 over -8. But 1 over secant is the same thing as cosine. So cosine is -1/8. That's all I need right there. Okay. It sounds tricky, but it shouldn't be too hard. Okay, going for the next one. Identify the quadrant for the angle theta satisfying the following conditions. We know that cotangent needs to be less than 0 and cosine needs to be greater than 0. So remember, guys, that is code language. Less than 0 means he's negative, greater than 0 means he's positive. So, and this is all based on all students take calculus. And remember, A stands for everybody's positive here, all. S is for sine and his reciprocal. And then we have tangent and his reciprocal, and then cosine and his reciprocal. This is where everybody's positive, okay? So you have to be a little intuitive to know where they're negative. We don't normally think with cotangent. The reciprocal of cotangent is tangent. So this still means tangent has to be negative. And we want cosine to be positive. So let's start with the easy one, the one that was kind of obvious. Cosine being positive. Everybody's positive here. And cosine is positive here. So we did this guy. Now we want of the two that we have listed here, the 2 that we've got circled, of quadrant 1 and quadrant 4, which one of these will tangent be negative? Well, we know that everybody's positive in the first quadrant, so tangent can't be negative there. So he's out. The only one that survived is quadrant 4. That's the one that meets both conditions. So we want A, quadrant 4. All right, let's see here. Find the exact value of the indicated trig function. Write fractions in lowest terms, which means you want to reduce them if you can. All right, so pay attention to your labels. We have A up here, we have B down there, all right? So it says find sine of A and tangent of A. Well, guys, this is basically asking you some definitions. Again, the some old hippie caught another hippie tripping on acid will work just fine. So some old hippie, and if you wanted to come up here and do cosine, caught another hippie tripping on acid. So we have opposite over hypotenuse, and then we have opposite over adjacent is what we're looking for. So this tells you where you have to look from. So are you looking from A or are you looking from B? Since it says sine of A, we're shooting from here. And you're wanting to go straight across. This is your opposite side. Hypotenuse doesn't change. He's always opposite the right angle. The adjacent side is always beside the angle you're investigating. Okay, so for opposite then we have 40. For hypotenuse we have 50. Well, we can reduce those zeros, right? So we have sine is 4/5. So not this one, not this one. Oh look, we got the answer, don't we? Now if you just wanted to make sure, the opposite side over there is 40 and the adjacent side is 30, and yes, the zeros cancel and you've got 4/3. This thing works like a charm. Okay, go to number 8. Without using a calculator, give the exact trig function value with rational denominators. Okay, so this means draw your pictures and use your special right triangles. Tell you what, let's finish up this problem and then we'll end this video. Tangent being 45. If this is 45 degrees, then that means your two sides, two legs will be 1, 1, and your hypotenuse is square root of 2. Well, remember, tangent is defined as opposite over adjacent. So the opposite side is 1, and your adjacent side is 1. So tangent of 45 happens to be 1. So this is the one we need, D, right there. Okay, we'll pick it up with number 9 in the next video.